There are an estimated 200 sextillion stars in the observable universe. That's a 2 followed by 23 zeros. If just 0.1% of those stars host habitable planets, that's still billions of Earth-like worlds. So why, in all this vastness, have we never made contact? Why is the universe so silent? In 1961, astronomer Frank Drake introduced a simple yet profound question disguised as an equation. The Drake equation wasn't designed to give us a precise number, it was a roadmap for thinking about life beyond Earth. In a single line of variables it asked, how many intelligent civilizations might be out there trying to communicate, just like us? More than 60 years later, it remains one of humanity's most hopeful and most haunting ideas. The Drake equation has 7 key variables: the rate of star formation in our galaxy, the fraction of stars with planets, the number of habitable planets per system, the fraction that develop life, the fraction of life that becomes intelligent, the fraction of intelligent life that builds technology, and finally, how long such civilizations last. Each step along this chain seems logical, even inevitable, until you try to assign real values. We know stars are abundant, but how common is life? And of that life, how often does intelligence arise? Worse yet, how long can intelligence survive? Civilizations may be self-limiting, burning themselves out through war, climate collapse, or runaway technology. Every variable is a cosmic gamble, and some scientists believe we're already past the odds. Let's unpack what we do know. Modern astronomy confirms that planetary systems are the rule, not the exception. The Kepler mission revealed thousands of exoplanets. The TESS mission continues the search. Systems like TRAPPIST-1, just 40 light-years away, have multiple Earth-sized planets in the habitable zone. But habitability is more than just distance from a star. It's about atmosphere, geology, magnetic fields, and stability. Even our definition of habitability is expanding. Recent studies suggest volcanic hydrogen may warm planets far beyond the classic Goldilocks zone. Then comes the real mystery, abiogenesis. On Earth, life appeared quickly, within a few 100 million years of our planet forming. But intelligence? That took nearly 4 billion years. And that raises the question, is intelligent life a rare evolutionary accident, or a universal outcome given time? Even if it arises, will it build technology? Will it reach out? And if it does, how long will it survive? A 2020 study estimated there could be at least 36 active communicative civilizations in our galaxy right now, but they'd likely be spaced so far apart, tens of thousands of light years, that contact might be impossible. Here's the emotional core of the equation, the paradox of hope. One interpretation suggests civilizations have emerged again and again, only to vanish before we ever had the chance to hear them. We might not be alone, just out of sync. Another view, offered by scientists like Frank and Sullivan, argues that intelligent life must be common, unless the odds are less than 1 in 10 billion trillion. If those odds are right, then civilizations like ours have likely risen and fallen across cosmic history. And yet, the silence persists. It's known as the Fermi Paradox. If they exist, why haven't we heard from them? Maybe the answer lies not in the stars, but in us. We've only been broadcasting for a century. Maybe others did the same. Brief bursts of signal, lost in the noise of time. The Drake equation doesn't give us certainty, it gives us a mirror, reflecting the limits of our understanding, our imagination, and perhaps our time. It tells us we may be early, or tragically late. Either way, it reminds us that we are part of the equation now, a variable in someone else's future calculation. So what do you think? Are we alone in this vast cosmic ocean, or just listening on the wrong frequency at the wrong time? Drop your thoughts in the comments, and don't miss our next deep dive into the universe's greatest mysteries.